The question says that straight line L has the equation of x minus y equals to 3. The curve C has the equation of 3x squared minus y squared plus xy equals to 9. L and C intersect at the points P and Q. Find the coordinates of the midpoint of P and Q. So first, let's start with putting both the equations equal. To do that, we're going to first make x the subject in the first equation. So we have x minus y equals to 3, which is our equation of the line. And I'm going to say x equals to 3 plus y. We're going to substitute this. Let's call this 1. Let's call this 2. Substitute in 2. So that's going to give us 3x squared minus y squared plus xy equals to 9. And this would change into 3 times 3 plus 1 whole square minus y square plus 3 plus y times y equals to 9. So 3 plus y whole square is basically 3 square plus 2 times 3 times y plus y whole square minus y square plus 3y plus y square. So we expanded the bracket over here. And then what we're going to do is we're going to further expand it. So that's going to be 3 bracket 9 plus 6y plus y square minus y square plus y square is going to be 0. So that canceled out. And we left with plus 3y. Now I'm going to bring the 9 to the left-hand side. So minus 9 equals to 0. Multiply the 3 with all of the terms inside the bracket. So 27 plus 18y plus 3y square plus 3y minus 9 equals to 0. 3y square is going to be as it is. We're going to collect the like terms. 18y plus 3y is 21y. And 27 minus 9 is going to be 18. So since 3, 21, and 18, all three numbers come in the 3 times table, we can further simplify this quadratic equation by dividing everything by 3. So that's going to give us y squared plus 7y plus 6 equals to 0. So now we have this quadratic equation and we have to factorize it to get the values of y coordinates for P and Q. So we know that 6 is 3 times 2 and 6 times 1. Since 6 plus 1 also equals to 7, so we're going to replace 7y with 6y plus y. And plus 6 comes as it is. Now we factor by grouping. First two terms get factorized separately. And last two terms get factorized separately. So that's going to be y, bracket y plus 6, plus 1, bracket y plus 6 equals to 0. Y plus 6 is common between y and plus 1. So y plus 6 in one bracket and y plus 1 in the other, which means one value of y is negative 6 and the other is negative 1. Now we find the corresponding x values for these y values. So for that, what we can do is we can substitute these y values in the first equation, which was x minus y equals to 3. So first we start with substituting y equals to negative 6. So that's going to give us x minus negative 6 equals to 3, which is x plus 6. Move the 6 to the other side. So 3 minus 6 and x is negative 3. So when y is negative 6, x is negative 3. So that's going to be minus 3, negative 6. Let's call this P. And for Q, I'm going to substitute y equals to negative 1. So that's x minus negative 1 equals to 3. x plus 1 equals to 3 and x is 3 minus 1, which is equal to 2. That means when y is -1, x is 2. So q is 2, -1. Now that we have the coordinates of P and Q, we have to find the midpoint now. So midpoint of PQ is going to be x1 plus x2 divided by y1 plus y2. That's going to be -3 plus 2 over 2 and -6 minus 1 over 2. -3 plus 2 is -1, so -1 over 2 is the x value. -6 minus 7 is -1, so -7 over 2 is our y value.